Okay, so good afternoon, everyone. So my name is Amit Kumar. I'm a PhD scholar in the Robert Boss Center for Cyber Physical System in IIC Bangalore. I will be your TA for the course Mechanics and Control of Robotics Manipulator. The instructor for the same is Professor Sant Kumar Mohan from IIT Palakkad. So this is just a practice assignment session for week 0. So today I will be discussing few questions from week 1 assignments for the last year assignments. This is uh, just for demonstrating the way in which we'll progress forward in this course. So this is the QR code from of the YouTube link. So if somebody is like miss this session, they can attend this session on the YouTube channel where it will be uploaded later on. So let's move on to the today's session. Question 1. So the first question uh, the first question which we'll discuss today is that what are the 4 Ds of robotics? So these are the options which are available to us. So design, detailed, dirty, and delicate, and uh, dull, dirty, dangerous, and difficult. So as we are talking about this robotics, we all know that the robotics have been, or the robots have been designed to facilitate some of the tasks of which human do. And as you go through these options, it is quite clear that there's one options which suits the demand or the requirement of the robots, which would be there. So that is the second option. So as you can see here, so we want a robot to do dull work, which like dull means that repetitive work or work which are dirty, also which are dangerous and the difficult. So we want to we want some machines to do these type of works and avoid as much as human interactions for this type of work. So the correct answer for this question will be dull, dirty, or dangerous and difficult. So these are the 4 Ds of the robotics, or the 4 major requirements for a robot. So the correct answer is dull, dirty, dangerous, and difficult. Now, let us come to the second question. Second question is like find the rotation matrix C with respect to A, and whereas rotation matrix with respect to rotation matrix of B with respect to A and C with respect to B is given. So what does that mean? That so suppose if you write here, so 0 minus 1 0 1 0 0 0 0 1. So if you write it here, so it represents that how will you rotate from B so that you will get it equivalent to A. And similarly, uh, this one represents how we'll rotate from C to get B. So what we want here, the question asked here is the C with respect to A. That means that we have to rotate or C to A. So what will be the transformation matrix? So we want a rotation matrix from C to A. That means that if we are at C, we'll have to go to A. So what we can do, we can rotate from C to B and then from B to A. So similarly, we can write it like this. So can write C to B rotation followed by uh, rotation from B to A. So this will be the transformation which we need to do to give to get uh, this rotation matrix C to A. So with that, we can simply find it out by simple matrix multiplication. So that will be 0 minus 1 0 1 0 0 0 0 1, right? And then we can multiply this with the second matrix, which is given 1 0 0 0 0 minus 1 0 1 0. So if you multiply, you will get this as it will get 0, then 0 1 1 0 0. Stand this 0 1 0. So this will be the correct answer. So if you look into the options, the first option is correct. So this will be the required answer for this question, as you can see here. So correct answer for the rotation matrix from C with respect to A is 0 0 1 1 0 0 0 1 0. Now let us move to the last question for this practice session. So the question is like that: this homogeneous transformation with matrix A T B can be decomposed to a matrix multiplication of A like a rotation matrix and transformation matrix. So this is rotation. This is transform. This is a translation. Sorry. So the question is, how can we write it as a mathematically? So so again, so as we have looked into the earlier question, so there we wanted the C matrix with respect to A. That means how we can rotate from C to get to A frame. So here we want that. So one thing we can go from B to A is through rotation followed by translation. So if you're doing rotation first, so it will be R A B and then followed by translation. So it will be written like D A B. So this will be the transformation matrix. So D A B. So this is the required answer. So the correct answer is for this question is this second one, and this we can verify using a simple example. So for that, you suppose if you take a translation. So for translation, we will have this like 1001. So this is just for 2D case we are taking. So A B 100, and then so this is translation, and so this is this part. And if we take rotation, put Z as 6 for as an example, 100 minus 1, and then this. So if we multiply this, what we'll get? We'll get 10 A 0 minus 1 A 0 0 1. So 0 B. Okay, so this is the transformation matrix which we are talking about here. So as you can see, this is the rotation part. So this is the rotation part, and here this is the translation part. Right. So you can verify this from this simple example. So the correct answer for this question is B. So with that, we'll in today's session. So we can again meet at the same time on Sunday, every Sunday, 3 to 4 to discuss the previous year's assignment of this lecture. And you can interact throughout this uh, duration, and we can discuss few questions which are important in this discussion. So with that, I would like to thank you for listening. We'll meet you again next week. Thanks.